before I start. I'm doing some trigonometry and I'm using Mount Wellington measuring the height as an example. We did this at Dominic College last year. I can't remember the exact inclination that we were at and the distance, so the maths won't work as such, but the theory is all good. Cheers. Hi everyone. Today we are going to carry on with our work on trigonometry. So we'll start by refreshing what we learnt in the last two lessons, where we learnt the three different functions that we use in trigonometry, and we also learnt the ratios. So we'll have a little refresh of that. And then we're going to use what we know about trigonometry to calculate the height of Mount Wellington. So we're going to apply the rules that we've learnt to a real life scenario. And then at the end of the lesson I'll give you a completely worded problem that I'll get you guys to work on your own to do. We'll sort of work together for the mountain one. So just to refresh and to go over what we've done in the last two lessons, who can tell me the three functions of trigonometry? You'll have to excuse my writing, you probably won't be able to see it. But yes, so you've got sine, cosine, and tangent. And who can tell me what ratios apply to each of those? Alright, so we have opposite over hypotenuse. We have adjacent over hypotenuse, that's right. And opposite over adjacent. And now, as we've talked about last week, a good way to remember these rules is with this, oops, it's so hard to write on here, SOHCAHTOA. Guarantee you remember that forever if you remember that little jingle. So these are the functions, these are the ratios they apply to, this is how we remember it. Now what kind of triangle does trigonometry apply to? Yes, so trigonometry is only used to calculate unknown lengths of sides for right-angled triangles. So again, let's just go over, we have a right-angled triangle, there's our right-angle symbol. Now, who can tell me what this side's called? The one opposite the right angle? Yeah, that's the hypotenuse. Now we do need, a lot of people get unstuck at this point where the right angle is not the angle that we are looking at when we're looking at the ratios. So if we are given this angle, just call it theta because it's not important at the moment, but this angle is now the one that we refer to when we're labelling the sides. So this side is opposite theta, so that side is opposite, and then this side is adjacent. I think if you do have trouble remembering these two, like the adjacent one is touching the angle, that's how I remember it. If you label hypotenuse first, that sort of gets one of them out of the way. So that's the most important thing when we're looking at trigonometry, especially when we're looking at real world examples. The first thing that you need to do is draw your right angled triangle, however it works, and we'll do this for the task we're doing today. But if you just start by labelling everything and understanding what you're given, like if you're given this angle, then obviously you need to switch these over. So that's sort of the most important step. People get a bit, it's a bit overwhelming when you're just given all the words, but you just need to take a breath and write it all out, because then you'll find that it's much easier. Just going to wipe my... Alright, so now that we've gone over our prior knowledge of what trigonometry is and how we use it, we are going to look at a real world example. So here we are at Dominic College, we can see the mountain out the window. We are going to calculate the height of the mountain using the information that we have at the moment. So we're going to do this together. I'm going to draw it out for you. So here's how the mountain looks from where we're standing. Here's me over here, not to scale. We want to know what this height is, a bit further. This is the height that we want to know. I'm going to call this x. So to use trigonometry, we need to draw in that triangle. So let's start by doing this one, and then you can see here this is our right angle, and then if we want to just finish off the triangle, so this would be the, yes, that's right, so this would be the hypotenuse. So we do know that without needing any more information, but what do we need to know before we can label what these sides are? Right, so we need another angle because we can't use our right angle. So we either need this angle or this angle. So which would be easiest, do you think? We're not going to be able to figure this one out, are we? Because it's at the top of the mountain. But we could, using inclinometers that I have a box of over here, we could all go outside and actually measure what the inclination is from where we're standing up to the mountain, and that will give us this angle. So let's all get an inclinometer and we'll go outside and do this measurement, and we'll come back with an average. Okay, so we've come back in, we've all figured out that we've got an average of 16 degrees. We're going to just use that, I'll just write it up here. So roughly 16 degrees. And the other thing that I'll tell you is that where we were standing was 1,200 metres from the highest point horizontally from the mountain. So now we can get rid of this theta, and we know this is 16 degrees. So now we can finish labelling the triangle. So what would x be? It's on the opposite side, so this would be the opposite. Just write it out to make it easy. And again, this one's touching on the angle, so this one's the adjacent. So which function of trigonometry will we use to calculate this x, the height of the mountain? Right, we'll be using tan because we have an opposite and an adjacent. The hypotenuse is not going to be important for this problem solving. So let's write out. So we have tan theta equals opposite over adjacent. So therefore tan 16, because this is our angle here, equals x over 1,200 metres. So therefore tan 16 times 1,200 equals x. So we've just times both sides and then brought it back over, so we've got x on its own, which means that x equals 1,270. Now, we also need to take into account the height that we were standing and holding it at. So I know that when I was holding it, it was 1.2 metres from the ground, my inclinometer. So we'll say the height equals 1,270 plus 1.2, which equals 1,271.2 metres. And that is the height of Mount Wellington. So I think the most important thing from this exercise is just to stop and think about what the information is telling you. Look at what extra information you do need. Most problems you'll get at least an angle, so having to go out and measure it yourself is not a step that you'll be getting in tests and stuff, but I think it's just important to understand that it's an easily calculatable thing. So I'm just going to leave you today with a worded problem, because I do want to get you trying to visualise, just checking the time, just trying to visualise this problem, because I think that is absolutely the most difficult thing people find in trigonometry is getting what they're imagining down on paper and labelling everything correctly, because we do want you to label, you've got to put in your little right angle symbol and put in your angle correctly and label the sides correctly. So I'm just going to say this to you, and then I will write it up on the board, and you guys can maybe just work in pairs to have a go at it. So first step, write it down and then draw a picture. So a 6-metre ladder leans against a building. If the ladder makes an angle of 60 degrees with the ground, how far up the wall does the ladder reach? And how far from the wall is the base of the ladder? So there's also another important part of that. It's a sort of a two-part question. I want you to figure out both unknowns. So I will also need you guys to correctly annotate the unknowns. So either have an X and a Y or an A and a B, but we need to differentiate when we're doing the working out so that we can see. And you will find you'll be using more than one of the trigonometry functions. So keep that in mind. We don't just use one for two different sides. The first side you're working on doesn't really matter, but make sure you keep that in mind. Okay, cool. And hands up if you need help.